All right. Hello, everyone. My name is Logan Ruthling, and today I will be talking to you all about open sourcing and the rise of the internet. Um, so today in my video presentation, I want to first talk about open sourcing and what it is. So get this to open and starts. All righty, open sourcing. So open sourcing is a very important concept. It extends and expands into various fields, including technology, research and development, the sciences, business models. It's a global concept that affects different constructs all across the world and is incredibly important today. So first, to kind of talk about open sourcing, we need to know what source code is. So source code is any collection of computer instructions that is readable by the facilitator of the computer code, and also the computer that's reading the code. So its function, the purpose of the source code is to help the user of the computer facilitate some sort of instruction so that the computer can take care of that instruction in a much more effective and efficient way, much more quickly than like you or I could do on the computer. So the way that these source codes are created, they're created by very smart people, by people who create source codes for a living to give computers commands so that they can perform a task within a very quick period of time and do it very well. So open sourcing generally refers to computer program with source code that is open to the public. Open sourcing, when it was originally created, was meant to be a collaborative effort amongst individuals in a community to design something and to share it so that people could come together and work on that code and add their own twist into it and make their own version and improve upon it. It's supposed to be the self-sustainable, self-growing code that people collaboratively work on. But in reality, it ended up not being like this. More people decided that they wanted to create the code and use the code to further their own purposes, to make their own individual versions of the code and not work with other people. And this is known as forking. So you're taking a code that was created by a group of people that shared this code with the community in a form of like an application or an app, for example, and taking it and then putting your own twist into it, making your own version of that app, and then using it for yourself. And that's called forking. So what is open sourcing? It's sharing ideas. It's what I said. It's different people coming together and collaboratively working on creating something that is beneficial to the public, and doing this via source code. Now, open sourcing is this, but it's also used as a developmental model, developmental model in the business world. It helps businesses promote universal access to designs of products. It allows a worldwide redistribution of these product designs. So I'll just go back to the app example. So applications on your phone, games, utilities, things that are helpful, like, like an app for speaking another language, like Duolingo. Those are all created through open sourcing and are able to be shared throughout the entire world and distributed throughout the entire world, so that there is a universal access to this. And when things are shared, this includes all subsequent improvements that are made to it by the people that went in and modified that app. So it's self-enhancing in a sense. And all of these are accessible through free licensing of applications and source code. So a little bit of history about open sourcing. The rise of open sourcing grew with the rise of the internet in the 1980s. There was a very, excuse me, a very large need for a retooling of computing source code. So the source code that existed needed to be reconstructed in order to more effectively and efficiently deal with the commands and tasks that its users wanted to complete. And with the rise of the internet, it was much easier for software developers to create source code that could do this, that could meet the functions and meet the expectations of its users. So we move into the open source software movement. So it arose to clarify the new structure of open sourcing that was on the rise with the internet, with the growth of the internet, to meet the increasing demands of its users, mostly Americans. So this environment was created by the new copyright, licensing domain, and consumer issues that people were having at the time in the 1980s and 1990s. So with these new things, it allowed for the internet to one grow, but also in tandem with the internet, the rise of open sourcing. And one of the biggest reasons why open sourcing developed was because of the limitations of proprietary code used by proprietary innovations and proprietary companies. There are a lot of limitations with proprietary code. It's not open to the public. It's created and copyrighted by companies who have copyrights and trademarks on that code and don't allow people to do anything or modify that code unless they buy it. And even still, in many cases, they're not allowed to modify the application or the source code. So it kind of stays stagnant unless the company decides to improve upon it. So in response to this, the open source software development grew, and it transferred into many fields, including the development of open source drugs, open source technology, and solar photovoltaic technology, which are all areas of either science or technology or research or engineering that utilize open source software development. And with open source software development, have been able to become self-enhancing because it's an open collaborative effort by not just proprietary companies like Microsoft, for example. So now we're going to get into the advantages, or some more advantages specifically of open sourcing. So one of the main principles of open source software development is peer production. This includes products such as source code. So when a group of people come together and they create the source code for a product or for an application, you have a lot of people working together to make that source code happen. And you also have a lot of people in the future who may want to alter that source code or improve upon it or add their own version to it to just keep on building upon what was initially laid down, the foundation. It's continuously built upon itself because of other people, because it's open to peer production in the public. And this comes at no cost. So it's a great incentive for public users to take their ingenuity and creativity and add what they can to the source code because they don't have to pay for it, which is contra to proprietary code. you do have to pay for that. So there's an incentive with open sourcing. And there's some other advantages too. It enables self-enhancing variety of production models, communication paths, and interactive communities. So what this means is that with the interactive communities, when you have source code that transcends into important parts of everyday life, like, for example, let's go back to the app. Example, you get your phone, has hundreds of thousands of different applications on it. It's an important part of my life. It's an important part of a lot of people's lives. So when you have people that are coming together and throwing out ideas to make these apps better for everyone, it really brings communities together. But it also has other advantages in business, for example. So production models. We'll talk later about that, about specifically how open sourcing positively influences businesses. But open sourcing software allows businesses to collaborate and to develop models that allow them to cut costs and be more efficient, as well as developing more efficient communication paths with one another and with different business nodes and business structures within their own company. So when you have companies that can communicate better with one another internally, that allows for them to cut costs and increase revenues. And I'll talk about that later. So why use open source? Well, first of all, it allows you to move away from proprietary applications. It gives you options, right? It gives you options. It gives you the ability to not have to pay for things like Microsoft Office or iTunes or Photoshop, which is non-free software. And honestly, it's a lot of money for a name brand, right? Like, sure, these products are good, but a lot of the money that you're charged for these products is just because of the Apple, right? The Apple logo or the Microsoft logo. When you can go and get an alternative open source application, which does nearly the same thing for free. You're buying something, you're not buying, you're getting something for free, which does nearly the same thing. And there are alternative applications for nearly every single proprietary application known. So there's Dia, StarUML, FreeCAD, which is contra to Microsoft Office, iTunes, and Photoshop. And like I said, they provide nearly the same services as these proprietary applications, and they do it for free. So let's talk a little bit more about the applications. So applications in different fields, right? I spoke earlier about how open sourcing affects different things like business models, research and development, engineering, science. So this first bullet point here: increased transparency and liberty in science. This really allows, and specifically in biotechnology, the example that I found in my research was open sourcing allows for companies or hospitals to perform surgeries on people that using open source applications that allow them to be much more efficient in responding or in noticing the symptoms and the problems that are going on within the human body, and they can do it in real time. So they're able to respond more quickly to things that pop up. Specifically, like if someone was about to have like a heart attack, they'd be able to detect and see the signs of heart attack symptoms before they even happen, because these open source technology applications, which have been built upon through collaboration, allow them to be able to detect these things. And there are many other applications that are proprietary that have been developed by biomedical technology companies that are sold to hospitals, but there are specific open source applications that do the same things as these proprietary company applications, and they're for free. So it saves a lot of money, and you can still save lives at these hospitals. There are open source applications in research methodologies, also in physical products and hardware. And a couple of these next slides will talk a little bit more about the applications that go underneath those. So computer software in medicine, so pharmaceuticals. There have been proposals for open source development, specifically the Tropical Disease Initiative and the open source drug discovery for malaria. So people are actually going to countries, scientists, researchers, and other people of medicine background are going to these countries and doing tests, specifically countries in Africa. I think in South America were the main continents of that countries that were having these discussions on. But they were going and doing tests on people, collecting samples, gathering data, doing research on different drugs, and they're submitting it to these applications that are open source that collect data all around the world, bringing it together on these applications, data done and collected by people in countries all the way from Nigeria to Brazil, and collaboratively gathering all of this data and using it to develop drugs to cure diseases that these people are researching. And so it's taking, sometimes scientists will try to be, this is my thing, I'm going to be the one who gets credit for this. And they keep all their research to themselves. And we have these people keeping research to themselves and not putting it together. They're not connecting the dots on all these things. It's not good for the overall long term, because you're not bringing all this data together. But open source allows you to do this, and allows you to be much more effective because you have all these people coming together and working together. So they're able to provide drugs for diseases, including malaria, which is a very big one in Africa. And there's also genomics, which is open source genomics. I'm running out of a little bit of time, so I'm going to speed this up a bit, which involves the rapid release of sequence data from bioinformaticians around the world. So again, just taking the data collected by bioinformaticians from around the world and taking what they've learned from their studies and using that to get more into the study of genes or genomics. So data science and engineering. So the first part here is science. There have been, because of open source applications involving scientific research, specific projects that have been created because of these applications. So first, the Open Source Science Project, which was created to increase student involvement in research processes by providing microfunding. So large government health-related organizations have been able to connect with students through these open source applications, provide them funding to allow these students to do research, to one, develop their own skills so that they can go into a science field and be doctors and whatever when they get older, but also when they're younger to be providing their time and their skills and their talents to work on research and development for science projects that cover the whole spectrum of science. That does also include research to cure diseases, like I previously mentioned. And then there's also the Science Commons, which was created as an alternative to expensive legal costs of sharing and reusing scientific data. Like I mentioned earlier, you have to pay money when scientists do this research, and they're like, it's mine. You're gonna have to pay me to get it because it's my research. The Science Commons is an alternative way for those scientists who want to share what they have learned with other scientists, so that those other scientists might have a better understanding or a better way of, advancing their own work because of what they learned from other people, other scientists. So it's really like this whole theme of like collaboration. So engineering. So there's this thing called the Hyperloop, which was designed by a collaborated effort of engineers through open source applications. And what it is, it's a high-speed transport designed from open source collaboration that uses linear motors and pressurized capsules. So I think when I looked at the diagram for this device, it was really cool. It's a high speed. What it is, it's a high speed. What it says, it's a transport, which very rapidly moves cargo and shipments. It's kind of like a conveyor belt, sort of, but it's a very complex, highly intricate and organized conveyor belt that goes, I think it was like 3.5 times faster, and doesn't make as many mistakes through with like conveyor belt. Traditional conveyor belt systems typically have flaws in their designs, which kind of mismatch products and send them to the wrong place. And these Hyperloops are designed to not do that, and to be 3.5 times faster. So it speeds up shipments, and therefore business models are improved. And then there's also the WikiHouse, which is an open source project for designing and constructing buildings, which is pretty simple. It's just an application that allows people to work on creating and designing homes and constructing buildings. So in summary, open sourcing is any computer program that uses source code, which is basically computer commands given to a computer by a user in a collaborative manner via free licensing. So this focus on collaboration, groups of smart, intelligent people putting aside their pride and their differences and working together for the common good. And this can be done because of free licensing. And with the rise of the internet and the internet's power and capabilities of connecting people, open sourcing has grown tremendously and is a part of hundreds of different applications and government research and scientific entities and bodies across the globe. And it has many advantages for its users. And it also contains many useful applications, which are, like I said, are used in many fields because they're just more effective and efficient, or just as effective as proprietary applications. And they replace proprietary software, which allows people to cut costs and not have to spend, a lot of excess money on, the logo. Like I mentioned earlier, like you're paying a lot for the logo typically, and these open source alternatives just give you what you need and for free. So it's very effective. And my closing statement would be that smart business leaders should move towards open source software because it saves them money. If you have a company that uses Microsoft applications and you've got 800 employees who have computers that use Microsoft, you've got 800 computers that need Microsoft. Microsoft sells it to you for $140 an application. That's 800 times $140. That's a lot of money. And you could cut all of that away if you used Dia, for example, which would allow you to do nearly everything that Microsoft Office would allow you to do, but for free. So it makes sense that people would move away from proprietary models. But that's all the time I have. Thank you guys so much for your attention, your patience, and the end.